In this video, we're continuing with a practical example of creating a steel shaft. This time, we'll build a ring construction using additional child objects as a group. If you haven't watched the previous videos, EL1.3 and 4, feel free to check those out before diving in here. Our goal for this step is to create ring constructions for the steel shaft, and by the end, it will look like this. First, activate the shaft. Under the newly added corner profiles, click Add New and then select User Component. Open No Profile, and under Common Components, select the Main User Component, which will act as our 0 point. The appropriate component group should be automatically selected, but it's always good to double-check. Now, rename this profile to something like Ring Construction 1 and activate it. To make things easier, I recommend pinning this as a project favorite so you can access it quickly later on. Now we can add a first profile to this ring construction. Select the I-type upright profile from the common components and rename it to Ring Beam 1. Great! Let's move on. Next, we need to modify the angle, size, position and color of the profile. Start by setting the angle to 90 degrees. Then, head over to the I-type group. For DXL, input the shaft depth. Set DXR to 0. For DY and DZ, let's use 200 mm, which is the same as the wall thickness. Now, go to the Location group and set X0 to -100. Lastly, in the Render group, pick a color. Let's go with RID 30,000, which is green. With our first profile ready, we'll copy it once and rename the one by changing 1 to 2. To position this profile, switch the position and angle calculation to manually by equations and use the 3D parameters. In X0, enter the formula 100 plus shaft underscore dx. Copy the ring beam again, rename it, and set the angle to 0. Input the shaft width for DXL. Then position it by entering shaft underscore dx in X0 and -100 and Y0. Copy this profile now and remove the minus sign in Y0 and add shaft underscore dy to position it. With everything in place, we'll position the entire ring construction in Z direction. Again, switch to manually by equations and use the 3D parameters. For Z0, enter pit or the relevant parameter. And then add 2600 mm. Great work! To finish things up, we'll copy the entire ring construction 5 more times. You can either copy all 5 at once or do them one by one, adjusting as needed. Rename the profiles and add the floor-to-floor distances. For most, it will be plus 3000 mm for Z0. But for ring construction 4, we have a different floor-to-floor distance, so input 3800 mm. For the last 2 ring constructions, since we don't have floor-to-floor distances anymore, you'll need to use different values. Add 3500 mm to ring construction 5 and 900 mm to ring construction 6. These groups remain independent, so you can modify any of them without affecting the others. Lastly, The dimensions for each additional object are generated automatically. If you'd like these dimensions to be visible in the drawing, just activate the component, go to the View Frame tab, and click on the red dimension icon in the selection group. That's it with how to create a steel shaft. Thanks for watching!